about the last time you worked on a high-performance team. You had a researcher, a designer, developer, a product manager. No one person did everything. Instead, the magic happened in between the gaps, right? The handoffs, the debates, and the shared vision. Now, let's imagine that the entire organizational structure exists inside a single piece of software. Welcome back to Human X Intelligence. I am Madalena Costa, and in our latest episode, we explore autonomy, the ability for a system to perceive, decide, and act on its own. But today, we are moving from the individual to the collective. We are moving past the single model era to the future that is not a giant all-knowing brain, but it's an ecosystem. For some time now, we have treated AI like a digital Swiss army knife. One tool with many blades. But as we give this system more autonomy, a single model starts to buckle under the weight. So, in product design, we actually call this complexity wall. The breakthrough to scaling past that wall is task decomposition. Instead of asking one model to design a product, we are breaking it down into specialized agents. You have a research agent for market trends, a code agent for modeling, and a user feedback agent for sentiment analysis. We call this distributed intelligence. This basically allows for parallel processing where our system does the 10 things at once instead of doing one simple, slow thing. This is an example that we can use for ourselves as we build products, or also, as I shared, how can we use it in our processes? But there's a specific study that I can remember that explored the multi-agent systems and how they can outperform single-agent models by over 90% on complex breadth-first queries. But why is that? Because you aren't just scaling a model, you're scaling a workforce. I saw the friction of this shift recently with a client building a next-generation travel application. We weren't just building a chatbot, we were actually building a travel orchestrator. But this is basically how I like to call it. But it was a travel app with multiple agents that gave a solution that was useful for the user. But how did we solve the problems that we are having? So we gave autonomy to 3 different agents: a search agent finding flights, a budget agent watching the wallet, and a preference agent that knew that the user hated layovers. On paper, it was perfectly perfect, right? But in the first live test, we watched a digital, I like to call it a digital civil war that break out, right? But the budget agent found a 200 euros flight and tried to book it instantly to win. But its specific goal of cost efficiency actually wasn't very good because it added 2 layovers and a 6-hour wait, the exact thing that the preference agent was designed to avoid. Because they were too autonomous and not sufficient coordinated, they started competing with each other instead of collaborating with each other. Well, the result with that was that to the user, the product didn't feel intelligent. It felt erratic. It felt like a team that hadn't talked to each other in weeks. This is what we call a drift. A drift isn't a bug. It's a structural reality of distributed intelligence. I shared a little bit, a tease on LinkedIn about this, about the drift, that we were going to talk about it. But this happens when your agent no longer share the same interpretation of the world. But there is actually another factor that builders often miss, which is the token economy. So before I explore more of this, we shared first how can we use this multi-agent system in our processes as product designers. We explored also how to design multi-agents for a product, but let's focus on token economy. Multi-agent systems work because they allow the system to spend more tokens on reasoning. In a single agent system, 80% of performance variance comes down to token usage. MAS allows you to bypass the limits of a single context window by distributing work. But however, there is a tax. So these systems burn through roughly 50 times more tokens than a standard chat. This means that as a product designer, we have to decide, is the value of the task high enough to justify the salary of this agent team? Is it? Is it not? We have to see it. But to fix that travel app and to move from simple autonomy to coordinated intelligence, you have to move from prompt engineering to orchestration. That's why I called it Travel Orchestrator. You need a 5-layer blueprint. At least this is what I like to use. Number one is intention, one global North Star. If the budget and preference agent disagree, the intention layer dictates which one wins based on the user current context. Number two, which is role clarity. Define exactly what an agent doesn't do to avoid duplicate work. Number three is the protocol. How do they share context? The budget agent needs to see why the preference agent is rejecting a flight. The next one is conflict resolution. Who is the tiebreaker? You need a lead agent project manager to resolve the civil war. And then we have, and the last one is evolution loops. You cannot judge a multi-agent system turn by turn. You need to judge it depending on the end state. Did the user get the flight they actually liked? What was the end solution? What did the user actually received? As these systems scale, they will look less like algorithms and more like organizations. So the core skill of the next decade isn't just models tuning and organizational design for intelligent systems, but there is the challenge when it comes to if we have these complex multi-agent teams working for us in the background, how do we actually talk to them? How do they understand what we want? Because they don't communicate the same way as us. They don't have the same language as us. So how can we make this connection and actually create something that will be used? So the text box, the chat interface is simply too small for this much power. So the textbook, the chat interface is simply too small for this much power. In our next episode, which is episode 9, we move from architecture to interface of intent. We are going to explore how we move beyond the text box and into spatial and ambient UI. How do we design systems that don't just wait for a prompt but behave with purpose in the space around us? I will leave you with this question. But if you want to see the technical diagrams of the travel app, travel orchestrator logic, and the orchestration blueprint of a travel app, we will share more about this on our Substack, so make sure to follow it at HumanX Intelligent at Substack. This Friday, I'm releasing this deep dive that I was talking about, which is on building the multi-agent research system. We'll be sharing the engineering part of the challenges, the memory management protocols, and the actual prompts we use to make agents reason reliably without spiraling out of control. But this was episode 8 of HumanX Intelligent. Like I said, I am Madalena Costa. Share this with someone building in the age of intelligence. I will see you next Thursday and see you on Substack this Friday.